Have you ever looked up at the night sky, wondered about its deepest secrets? What if something out there could just vanish, not hide behind a planet or a cloud of dust, but truly, utterly disappear from the universe? As if a cosmic trapdoor opened wide, swooping up light, matter, everything. Where could such a place exist? This isn't just a science fiction story. The universe holds such amazing mysteries. Imagine a force, a pull, so incredibly strong nothing can resist it. Not the fastest spaceship we could dream of. Not even light itself, the speediest thing we know. This force is gravity, but not as we feel it every day. These cosmic vanishing points are real. We call them black holes. They challenge our understanding of space. Prepare to be amazed by the universe. What is a black hole in simple terms? It is a place in space, a region where gravity is super strong, so strong that it pulls everything in. Nothing can move fast enough to get away. Think of it like a cosmic waterfall. But instead of water, it's space itself flowing, and the flow is too fast to escape. Now the name black hole can be tricky. It sounds like an empty hole, a void, but it's not empty at all. It's actually a huge amount of stuff, an enormous quantity of matter, all squeezed into an incredibly tiny space. This makes its gravity unbelievably powerful, more powerful than anything else we know. Imagine taking our entire planet Earth with all its mountains, oceans, and cities, and crushing it down, smaller and smaller, until it's the size of a tiny sugar cube. That gives you an idea of the density, the sheer amount of stuff in a small place. This extreme density is key to a black hole. How does such a strange object come to exist? Most black holes are born from stars, but not just any star like our sun. They come from truly massive stars, stars that are many times bigger than our sun. These giant stars live fast and die young. Their death can be a spectacular event, leading to the birth of a black hole. Stars are in a constant battle. Gravity tries to crush the star inward. The star's nuclear fusion creates energy. This energy pushes outward, fighting gravity. For most of a star's life, these forces balance. The star remains stable, shining brightly. But what happens when a massive star runs out of fuel? Its nuclear fusion engine starts to sputter. It can no longer produce enough outward pressure. Gravity, relentless and ever-present, takes over. The star begins to collapse under its own weight. This collapse is incredibly rapid and violent. Section 4. Inside the Abyss Event Horizons and Singularities. Black holes have some very special features. One of the most famous is the event horizon. Think of it as the black hole's border. It's not a solid surface you could touch, it's more like a point of no return, an invisible boundary in space. Once you cross it, you cannot go back. Your fate is sealed within the black hole. Why is the event horizon so important? Because it marks where gravity becomes inescapable, even for light, the fastest thing in the universe. If light crosses the event horizon heading inwards, it cannot turn around and escape. This is precisely why black holes are black. No light can bounce off them, or be emitted from within. They are truly dark to our telescopes. At the very center of a black hole lies the singularity. This is a word physicists use. It means a point of infinite density. Section 5. Cosmic architects. The universe's heavy lifters. Black holes might sound like cosmic monsters just swallowing everything in their path. And it's true, they have a powerful appetite. But they are not only agents of destruction, they also play a very important role in the grand structure of the universe. They are like cosmic architects, shaping galaxies. Their influence is felt far and wide. Many galaxies, including our own Milky Way, have a supermassive black hole at their center. Ours is called Sagittarius A*, said A-star. It has a mass of about 4 million suns. That's incredibly huge, yet it's typical for the centers of large galaxies. These giants didn't form from single stars. Their origins are still a topic of research. The immense gravity of these central black holes helps to hold the galaxy together. It influences the orbits of stars and the movement of gas clouds nearby. They can affect how stars form in a galaxy, sometimes triggering bursts of starbirth. Section 6. Black hole myths and marvels, truths, and tall tales. There are many popular ideas about black holes. Some are true, some are myths. One common myth: black holes are cosmic vacuum cleaners, that they roam space, sucking up everything, like a hungry monster on the loose. This isn't quite right. They don't just pull everything towards them. Their gravity works like any other object's gravity. If our sun suddenly became a black hole with the same mass, Earth would not be sucked in. We would continue to orbit it just as we do now. It would just get very cold and dark. You have to get very close to a black hole, inside its strong gravitational influence, to be pulled in beyond escape. So no need to worry about random attacks. Here's an amazing fact though, black holes are not perfectly black. The famous physicist Stephen Hawking discovered something. He found that black holes can slowly leak radiation. This is now called Hawking radiation. Section 7. Peering into darkness. Why we study these giants. Why do we spend so much time and effort trying to understand these dark, distant objects? Studying black holes is incredibly important. It helps us test our theories of gravity, especially Albert Einstein's theory of general relativity. Black holes are extreme environments where gravity is at its most powerful. They are perfect laboratories for Einstein's ideas. Black holes push the boundaries of physics. They force us to think about new ideas, like what happens at a singularity, or how gravity works with quantum mechanics. These are some of the biggest questions in fundamental physics today. Black holes offer clues if we can find them. They challenge us to be more creative. Understanding black holes also helps us understand the universe. How did galaxies form and evolve? What role do supermassive black holes play? How do black holes affect their surroundings? By studying them, we piece together cosmic history, from the early universe to the present day. They are a key part of the universe's story, a story we are still learning to read.